So here goes the quiz example. We need to evaluate this particular integral, and you probably have it in different different variation of the same example. We have the integral of x cubed dx in the numerator over the square root of x squared plus 121. Well, 121 is a perfect square, it's 11 squared, so this thing smells like a trig substitution, and we have something squared plus something else squared, so we're going to substitute. We're going to say that x equal 11 tangent theta, okay, because tangent squared plus 1 will give us the secant squared. So we need a substitution for dx, so dx will be 11 secant squared theta d theta. Something to keep in mind, that the tangent by itself, tangent theta is x over 11, and also that I think that's pretty much what we need to do. So now the integral I, after this substitution of x dx divided by x squared, and I'll write it as 11 squared, like so, equals, if I'll do the substitution, well, x squared becomes 11 cube, I'm sorry, x cubed becomes 11 cube, tangent cube, and then dx is 11 secant squared. So we have dx is here, and this is x cubed, and the denominator is the square root of 11 squared tangent squared plus 11 squared. All right, so let's see. We're going to have 11 outside the square root, so we're going to reduce it with this 11 of the differential, but we're going to stay with 11 cubed. So I'm going to take it outside the integrand, outside the integral actually, and what I have left is the tangent cube times the secant squared, the theta on top, and at the bottom, doing mentally, factor out the square root of 11 squared, which is 11, and reduce it with this 11. So we took care of that, and what we have left is the tangent squared plus 1, the square root of the tangent squared. I might as well go ahead and write it, although this is something you can do mentally, and then you end up having 11 cube tangent cube secant squared the theta, and of course by the Pythagorean identity this is secant squared, so square root of secant squared produce the secant of theta, and at this point we have 11 cube, and I have tangent cube times secant. I love the tangent secant combination, so I'll have the tangent squared, and then I have the secant times tangent d theta, so I split it like so, and that's it. I have no more, I have no denominator here, okay? And now I'll let u equal a secant. Well, there is one more step to do. The tangent squared is secant squared minus 1. So this will be equals to, so let me use a little bit of whiteout here. So one step before we'll do the substitution, but you can see the motivation here. We love to have secant times tangent d theta, or cosecant times cotangent d theta, or the secant squared d theta, or the cosecant squared d theta, because those are easy. Those are non-differentiable differentials, and we know what is the antiderivative in this case. So, wrong pen here. Hopefully this is dry enough. So we have 11 cubed, and instead of the tangent squared, we'll substitute with the secant squared minus 1. And here we have the secant tangent combination, d theta. And now we let u equals the secant, and therefore du equals the secant tangent combination, or product. And the integral I is now 11 cubed, and we have the integral of u squared minus 1 du. And of course the result will be 11 cubed. What the heck is 11 cubed? Well, let's not worry about it. And then the antiderivative here will be u cubed over 3 minus u, and of course the ever-present c. So we are done here. Now we need to go back and resubstitute. So we end up having the result written in terms or expressed in terms of x. So now we're going to take the journey backward. All right? So u is secant theta. So we end up having 11 cubed times secant cube over 3. And then minus secant plus c. So that's one back substitution. And now I'm looking and I say, wait a second, x was defined as 11 tangent theta, or tangent theta was x over 11. I need to recover the secant. I can either use the Pythagorean identity, or better yet, construct a very powerful right triangle, like so. And by definition, I'm looking at tangent is x over 11. Well, the tangent is opposite over adjacent, and therefore the hypotenuse is x squared plus 11 squared. And notice that this is the radical that we started with. It's always the case that one of the sides, when you do the trig substitution, you go back to use the triangle to undo the trig substitution, you end up recovering the radical. Okay? So I need the secant. Well, the secant will be the hypotenuse over the adjacent. So secant theta is the square root of x squared plus 11 squared divided by 11. And now the integral, the result of the integral, can factor out the square root of x squared plus 11 squared and get a simplified result. But go back here, right, and do the following. I equal, we leave the 11 cube outside. There is not much I can do about it. But now I'm going to write it 11 cube over 3 and get a secant cube of theta minus 3 secant theta, like so. And then factor out the secant, so get 11 cube over 3, secant theta times secant squared minus 1, right? That's what you did? Okay. Now, what is the secant squared minus 1? It's the tangent. So, it will be minus 3. So we're going to leave it as it is. Okay? And now we're going to go back and do this substitution that we wrote here. Okay? On the next page. It's better because what I intended to do, you see that you have the factor, the secant theta. What I intend to do is factor square root of x squared plus 11 squared over 11, which is the secant. But this is better because it's already factored. So this should be the next step. Isn't that? So we end up 11 cubed over 3. Now we do the substitution. So the secant by itself is the square root of x squared plus 11 squared, or 121, over 11. And then we need to multiply it by the secant squared. Well, the secant squared will be simply x squared plus 121 over 11 squared. I'm debating whether to leave it as 11 squared or not. I think I will as 11 squared. And then minus 3. Okay? And since I want to have a common denominator, it will be minus 3 times 11 squared. Like so. Okay, you see what I did? Okay, and now we can, what happened is you can see that 11 cubed and 11 cubed disappeared. So we have 1/3 outside, and here we have the square root of x squared plus 121. And what's left here is x squared times, this is 3 times 121, and this is plus 121. So you end up having a net of 2 times 121, or 242. So minus 242, like so, plus c. Because of the radical, we're going to just write it in a different order, just so we won't mistake entering the whole numbers into the radical. So we're going to write it like so. Again, the reason for this particular example is I want to show you how you manipulate the solution after you finish the integration.